So in this question, we're being asked to find what V, the volume of the cone or of the water, is in terms of R. We know that up here, the volume of a cone is this formula. However, this formula is in terms of R and in terms of H. So we want to find out what this volume is only in terms of R. So we need to work out what R is in terms of H. So to do that, we can draw a two-dimensional cross-section of the cone where this is 3, being that this area here is what we're drawing. This is R. This here is H, because it's the depth of the water or the height of the water. And this length here is 8. Similar triangles tells us that R divided by 3 equals H divided by 8. From that, we then know that R equals 3H on 8. Yep, or 3 over 8 H. And that H equals 8 over 3 R. Beautiful. So what we want to do is we want to sub this value of H up into there, and that'll then give us VR equals 1 over 3 pi R squared times by 8 over 3 R. And that simplifies down to 8 over 3 times 3 is 9 pi R cubed. Cool. The next part of the question asks us to find the rate at which the surface radius is changing at the distance when the water is 5 meters deep. So if we know that V of R equals pi R cubed 8 or 9 pi R cubed, if we differentiate both sides with respect to time, we know that R is a function of time because R changes with time, which means that we're going to have dV over dt equals the differentiation with respect to time of 8 pi R cubed divided by 9 in there. It's a bit messy. The question tells us that the wording for it is the water exits the tank at a rate of 0.2 meters cubed per minute, which means that dV over dt equals negative 0.2. Therefore, negative 0.2 equals the differentiation of this function. So to differentiate that, we're going to differentiate, so R is a function of t, so what we're going to do is differentiate R to start with. So we're going to have 8 over 9 pi R squared times by 3 times by dr over dt, and that's a product rule there. The chain rule there. So this is now equal to minus 0.2. 8 over 9 times 3 is going to become 8 over 3 pi R squared dr over dt. The question is asking us, find the rate at which the surface radius is changing at the instant the water is 5 meters deep. So we know that back up here, when it's 5 meters deep, H is equal to 5. So we plug in 5 into this here, which implies that when H is equal to 5, R equals 15 over 8. So putting that back into these equations, minus 0.2 equals 8 over 3 pi 15. Oh, the pen stopped working. Just give me 1 sec. 15 over 8 squared dr over dt. Therefore, minus 0.2 equals 8 over 3 pi 225 over 64 dr over dt. And then if we rearrange that, because we're being asked the rate at which the radius is changing, dr over dt is obviously the rate of change of r with respect to t. So we can rearrange that, and that'll give us minus 0.2 times by 3 over 8 divided by pi times by 64 over 225. It's a bit of a really messy way to rearrange it, but obviously I know that you know how to rearrange stuff, so that's fine to do it however way you want. And then if you plug that into a calculator, well, that simplifies down at the start to minus 8 over 375. Sorry, my page has run out again. Just drawing that up over here. That'll simplify down to minus 8 over 375 pi. And then that will give you an answer of in all honesty, I wouldn't put that in a calculator. I just leave it as an exact number. So minus 8 over 375 pi meters per minute.